Hello, my name is Christina. I am a computer science student at the University of Texas at San Antonio, and I'm presenting today on the path to post-hackathon success and how to not get too lost in the maze of finding a career in technology. So you're working on a project and you got it to run. Maybe you even got a hackathon recognition from being able to demo it successfully. But let's be honest, your project is probably a duct-taped monster you cranked out nearly sleepless. You're most likely not considering good engineering practices like good test coverage, security, or scalability. Because after all, it's just a 2-day project you needed to ship out quickly and you might just forget about right after the hackathon. When you begin to let the neglect of bettering your project or yourself seep in, you're cutting off the larger positive benefits that hackathons can provide, especially the benefits for preparing a career in the tech industry. So, I'd like to share the path to post-hackathon success. The title might be a bit misleading because truly there is no one singular path, as everyone has different interests and skills and their own personal methods of success. It's also important to note that everyone has their own pace. Don't rush through anything just because you feel like other people are part of the hustle culture. In fact, remember to take care of yourself and that finding a career in really any industry is truly a means to that end. So, I hope the resources and advice I've gathered in this presentation will help shine a light in the dark forest of the tech industry. You should personally customize the elements that would work for you. Some of the information are things I had to learn through time and trial and error on the path of landing my internship at a big company. So hopefully I can save others the headache and confusion. The 4 main categories I'd like to go through today are career tips and resources, expertise-focused learning, evolution, not revolution, of existing projects, and the startup route, aka an introductory field guide for technical founders. This is a slide with some of the most notable employers that the UTSA University Career Center is actively engaging with. Rowdy Hacks is directly corresponding with some of these employers, and you should take the opportunity to attend some of those company sessions or ACM talks hosted by companies and ask about their culture, their teams, how to apply for a job, etc. I think raising your hand and asking questions, especially when the company is there specifically to answer your questions, already puts you in their sight. Then you can follow up with employers through networking platforms or sometimes emails. Here's the slide the University Career Center has to offer in terms of building and managing your career. Each of these is its own thing, and don't worry about getting too bogged down into the details of every single one of these resources. In fact, I recommend just choosing 1 or 2, focusing your energy in updating your profile, networking with hiring recruiters, peer mentors, and potential coworkers, and updating your resume. I can give some resume-specific tips after this talk, but for brevity, the university does provide resume workshops and the Career Center that you can easily search up. In terms of preparing for coding interviews, there are concepts that are fundamental in the programming world. Most of the technical interviews are meant to discover your problem-solving skills, and knowing these concepts, besides mastering a programming language, is something you should be familiar with. I'm not going to go into depth as each one of these can be a presentation in itself, but feel free to ask me questions or ask for resources after this presentation. On a high level though, the topics that you should prepare for are algorithms and data structures, computer organization, operating systems, coding, and system design. Your first job will not require you to understand everything about programming, but it's important to be able to approach and solve common problems. Now as to expertise-focused learning. This is somewhat a broad topic, and I will approach from a general perspective that might be useful to the pre-graduate programmer. What I've observed is programmers are willing to put in the hard work, but are often stuck at what might seem the easiest stage, the pick. The pick? Well, that means choosing what language or technology or skill you want to focus on. With a myriad of languages out there, you might be still wondering, well, is Python a good language, or something along those lines? This is an especially hard choice when you also consider that it will take hundreds of hours to practice to become proficient in any language. The simplest answer to that question is choose what you want. This does come with some caveats though. First, ask yourself what you're passionate about. Do you want to build mobile apps, websites, video games, microprocessors, operating systems, etc.? Do you want to manage products, design and maintain distributed systems, or conduct PhD level research? For this, I recommend doing some research. That might mean knowing which class you enjoy the most in college, how you want to contribute to society or an industry, if you're interested in other fields, what type of cross analogies there are, or what internship and research labs interest you. Now with that, a more intelligent way to answer the question of choosing what to learn is, what should I know to get hired at a tech company as a blank? Here's an infographic that might help. You're welcome to take a picture of this for your future reference. This might be somewhat old and only serves as an introductory map, so my recommendation is still to search up job-specific criteria and qualifications. Infographic LOR themed. This might help you understand what you might enjoy learning and how your personal goals align with certain languages. Here's a quote. Computer science education cannot make anybody an expert programmer any more than studying brushes and pigment can make somebody an expert painter. So know that academia, which tends to focus on low-level of abstraction languages like C or mathematically focused languages such as MATLAB, may not always reflect the languages used in the workforce. In fact, if we're looking at what languages are mentioned most in job postings as of 2016, Java comes in first, and JavaScript comes in close second. There are 2.7 Java developers competing for every open Java position. Competition for PHP and iOS jobs are similarly fierce. But for every JavaScript position, there are only 0.6 JavaScript developers. I'm not going to argue which language is the best, but I'm an advocate of JavaScript and I can give you some personal reasons why I think it's one of the best beginner programmer languages to learn after this talk. The average JavaScript project receives twice as many pull requests as the average Java, Python, or Ruby project. And on top of this, JavaScript is one of the fastest growing, if not the fastest growing, popular language. JavaScript's ecosystem also benefits from a heavy investment of money and engineering talent from companies like Google, Microsoft, Facebook, and Netflix. For example, TypeScript, a statically typed superset of JavaScript, has more than 100 open source contributors, many of whom are Microsoft and Google employees being paid to work on it. If you're going to take anything away from this information though, understand this. If you keep jumping from language to language, you won't get far. In order to move beyond the basics, you need to learn your first language well. Then your second language will be much easier. Learn the broad concepts, such as algorithms and data structures. From there, you can branch out and become a more well-rounded developer by learning lots of languages. C is a great way to learn how computers actually work in terms of memory management, and it is useful in high-performance computing. C++ is great for game development. Python is awesome for science and statistics. Java is important if you want to work at large tech companies. Okay, on to the next topic, evolution, not revolution of existing projects. It's good that you're working on a project for a 2-day hackathon, but it's great for learning and your resume if you're taking that project and working on it over a longer period of time. There are many aspects that contribute to the continuation of projects so that they're more long-term. But one thing that's not so intuitive that has been verified by research is that the projects of teams who worked on ideas that were similar to existing or planned products or could be perceived as suitable extensions of such were much more likely to be continued than those who developed radically new ideas unrelated to the existing product portfolio. How do you evolve your project? Well, there's a few things to consider. What tech stack or infrastructure are you using? Is that AWS, Google Cloud, or ECS? What front-end and back-end tools are you using? React, Python, Go, C++? Some considerations might include thinking in terms of writing code efficiently that your algorithm wants and cross-compiling it with specific architecture. Other considerations is creating a good user experience. If your product is centered around data, for example, then how should you rapidly query data or render complex queries? Consider how to transfer innovative research prototypes into products or technology transfer. Now to expand a little bit more on technology transfer. What makes a successful transfer is product effectiveness in terms of fit with existing products or competencies, as well as market demands and resources. This might mean identifying organizations that perceive your product to fit into existing products, or if you're willing to develop a similar product and this organization is willing to spend resources on the future development of your project. Believe it or not, UTSA has that organization. It's called the Office of Commercialization and Innovation, which I've linked above. They provide intellectual property management and licensing, proof of concept development, new venture incubation, and entrepreneurial training. If you're still with me, then this serves into the perfect segue for the self-starters who are interested in becoming an entrepreneur or doing things on your own. If you fall under the category of being ambitious and having a bias toward action, then you likely already have the mindset to undergo the ruthless processes of starting your own business. But for the average student, I would imagine that most of you are not considering starting your own business. In fact, my own personal recommendation is to first study and gather as much information as possible in your college years. If that means first entering a corporate job and understanding the best business practices and processes, then you should do that. But if you think the classic college education is not preparing you as much as getting hands-on experience, and you have a dash of crazy, then there's no stopping you in taking the initiative. Also, it's not so much that your major matters, but rather that you have found something that you're eager and willing to dive deep into. If you are really intrigued by sustainable fashion, for example, learn who the industry leaders are and what materials they use. If you're interested in cryptocurrency, immerse yourself in the underlying technology. I would strongly recommend that you consider learning some technical skills while you are a student. Furthermore, this information may be useful for those who want to join a startup instead of necessarily starting one. But first, I'd like to unravel a lot of the misconceptions students have about beginning or joining an entrepreneurial project. I'm going to consider all of the reasons why you aren't doing it and show why most of them should be ignored or why they can be easily overcome. Some reasons why you may be telling yourself not to get involved in startup is that you're too young, you're too inexperienced, you're not determined enough, not smart enough, know too little about business. You have no co-founder, no idea, and you need to focus on your coursework and GPA. So why should you be interested in starting a technical project, learning about business creation, or creating a startup venture? College is a prime time for intersecting your technical and academic specialties with servicing people. DoorDash was founded by Stanford undergraduate students, and Sam Altman started his company Looped at age 19. As a college student, it is imperative you start thinking about ideas and networking. This is the foundation of a startup, an idea and a co-founder. The best way to get experience is to start a startup. If you're too inexperienced to start a startup, what you should do is start one. It's a much more efficient cure for inexperience than a normal job. In fact, getting a normal job may make you less able to start a startup depending on certain conditions, such as proprietary technology, office culture, etc. There's no better time to take risks when you're young. You'll probably fail sometime, but even failure will get you to ultimate goals. Failing early is learning early. In fact, even failing at making a startup is incredible experience for a resume. You're much more likely to get a job if you know the ins and outs of product design and business management firsthand. Most people probably underestimate their determination, especially if you're a hardware or software developer. Starting a project of your own reveals passion and authenticity about your craft or visions, and determination is probably the best predictor of success. If you're already worrying that you might not be smart enough to start a startup, you probably are smart enough, and if you're at this meeting, you are probably already ahead of the crowd. Think about what you like to intellectually develop yourself in. Most companies do a lot of mundane stuff where effort and not brains get things done. So think about your personal goals and how to take initiative while you are a student. I think it's important to reward your brain and be rewarded for your brain. You don't need to know anything about business to start a startup. The initial focus is the product. All you need to know in this phase is how to build things that people want. Software companies should be built by software people. Hardware companies should be built by hardware people. If you succeed, you'll have to think about making money, but this is so easy, really, that you can pick it up on the fly. And if you're a business student and you don't know how to code, then you're also in a place where people do. If you don't have a co-founder, what should you do? Get one. It's more important than anything else. It's important to build a strong network of entrepreneurial peers and mentors. Unfortunately, startups generally only look to hire new talent when the company absolutely needs it, oftentimes well after the understaffing becomes apparent. You need to embed yourself into the greater entrepreneurial community and form meaningful connections. As to having no idea, a possible approach you might take is finding something that's missing in your own life and supply that need, no matter how specific to you it seems. If you're working toward landing a job at a renowned or large company, or if you're working toward graduate school, consider what you need on your resume and who you need in your professional network. You may need a reference from someone you connect to so that the hiring recruiter or the graduate admissions office notices you. Self-driven projects demonstrate determination and passion. Again, this is incredibly important for applying to jobs or graduate school. It separates you from the rest of the crowd and might even justify for a low GPA. Pick up knowledge on real applications and latest trends, and utilize the college experience for what it is best for. Connect to a broader, interdisciplinary, collegiate, and academic network, and learn effective communication. Expand your resume with campus involvement and expand your list of accomplishments by delivering your project to a competition or conference. A great first step in forming meaningful entrepreneurial connections is to tap into the entrepreneurial ecosystem at UTSA and in San Antonio. A few of some resources I highly encourage to look into are Site, CivTech SA, Geekdom, and Blackstone Launchpad. Every year at UTSA, Site hosts the 100K Student Technology Venture Competition to give students hands-on experience as early-stage entrepreneurs. Teams of interdisciplinary students work throughout the semester to develop a technology demonstrator and a business plan to successfully develop into a new company. Here's a really extensive list that illustrates how vibrant the San Antonio startup ecosystem is, and please feel free to take a picture for future reference. So how should you get started in starting a startup? First, set aside time. Does that mean 2 to 3 months full-time or 1 to 2 years part-time? Find product market fit. Interview users who might use your product. Decide whether your product serves public or private markets, and find a sustainable business model. Now, what about the trade-offs between good engineering practices, like I mentioned at the beginning of the presentation, the practices that involve scalability, test coverage, reliability, and security, and the speed of shipping a product out? Speed is paramount in early days, but it really is a balance, and you want to constantly incorporate your learning in development. But as you find product market fit, scale your project, have more people contributing to it, there will be new problems and possibly a lot more ways for your system to break. Also, depending on your product market fit, you might need to prioritize some aspects over others, such as speed and scalability over security for one period of time. Some important things you should consider then is running unit tests so that each developer on the team can verify that the code works, introducing CI/CD and integration tests, code reviews, reproducibility, etc. Various engineering methodologies such as agile development, test-driven development, OKR framework, which is used by Google, etc., can be used. Find what works for your team, whether that means using some agile elements and elements of other frameworks. Communication and time boxing are important, and as you grow with a bigger team, you'll constantly evolve how you grow. There's no easy answers to these questions though, so it really depends on your personal project. In my presentation, the following slides are a few inspirational maps of what the startup ecosystem looks like in vastly different sectors of society and economy. I hope by talking with you all today, I've given you some inspiration to learn something new or even for your next hackathon project. I wish you all luck in your search for finding success in the tech industry.